The American Weather Channel shares a lot of articles with Weather Underground, and I'm currently on the Weather Underground website, but this article and video actually comes from the Weather Channel, and it's on supercells, what to know about these dangerous thunderstorms. And this article was published on Monday, 24th of April 2017, and today in Australia it's the 25th of April. It's about 20 past 10 in the morning, and Jacob Wetterling and Nathan Breeze, two boys who I think I have a bit of a connection with, who are no longer here on Earth, they seem to have drawn my attention to my birthday, which is Thursday, 27th of April 2017, and also to the date Sunday, 30th of April 2017, and of course that's 1st of May in Australia. But there was a pretty big tornado on Good Friday, and I've been thinking something's going to happen a certain number of days after Good Friday, which might reflect how old Jesus was when he died. And I know that's pretty way out kind of idea, and it's certainly not a scientific idea, but it's probably got more to do with Carl Jung and synchronicity than science. However, it's just a feeling I've got, which I think has come from Jacob and Nathan. And 16 days after Good Friday, the date will be the 30th of April. My birthday is 13 days after Good Friday, and that's the Thursday, like I said. So I'll start off just sharing this video, supercells, what to know about these dangerous thunderstorms. And this video is how to spot a supercell thunderstorm. And like I said, it's from the Weather Channel, the American Weather Channel, and it's quite a good little video, so I'm just going to share it with you now.
Supercell thunderstorms, I bet you've heard of them before. They're big and nasty, they create severe weather, they drop hail, they can drop tornadoes as well. I want to give you a couple of tips on how to spot these guys, not only out in the field, but on radar, which we'll talk about in a minute. First, let's talk about the definition of a supercell. It's basically a rotating thunderstorm, alright? And look, if you're out in the plains and you're really far away from one of these things, super easy to see. You got the big mothership structure there. Now, it's down at the bottom of the storm where things get a little bit interesting, and this is where it's a little bit more difficult to pick out certain things. Here's one thing to watch for in a supercell: inflow tail, all right? So this is basically the warm, moist air being sucked into the storm. Sometimes storm chasers will call it a beaver tail, but that is not a funnel cloud. I know a lot of people will mistake it for that, but basically that is an indication that you're going to have a storm that's probably rotating. Now, this whole wall cloud part of the storm, it's so small compared to the size of the storm. It's crazy. When you look down at these things on radar, they look pretty small, but in the 3D, I mean, they're 50, 60,000 feet tall, and the tornado-producing part of the storm is actually very small compared to the rest of the storm. In fact, this is even probably a little bit too much of a size idea there. So, how do you pick out a supercell on radar? You're looking for a hook echo, basically, okay? And this is an indication that the storm is rotating, okay? You see that little hook that comes down on the southwest side of the storm? It's easy to pick out when the storm's by itself, but sometimes you'll get a line of storms, and usually a line of storms will just come through kind of damaging wind, but sometimes you can get these little embedded supercells within lines of storms. Look for little hook echoes when you see lines like that. That's an indication that the storm can be rotating.
There you go, pretty cool little video on supercells and how to spot them. If I just go through the rest of the article, the term supercell is used by meteorologists to describe a breed of long-lasting thunderstorm which rotates and is accompanied by dangerous weather conditions, including large hail, damaging winds, and sometimes tornadoes. Classic supercells appear as individual storms, like the one in the radar image below. If I just bring that into view, and that is an actual radar image of a supercell, and that image goes back to a storm in southwest Oklahoma on November 7, 2011. The Hook, Echo and Hail core are labelled. This is from the National Weather Service. So the area with the most hail and heavy rain in the storm, which can include hail up to the size of baseballs, is in that area there, in a large supercell. And if you're going to get a tornado, it'll be down here, in the Hook Echo region. However, as he was just saying in the video, these supercells can sometimes be embedded within a cluster or a line of thunderstorms. When viewed in an open area, classic supercells have the mothership appearance that is often photographed in the plane states. So this is a very famous photo that they've included here, and this one was taken by Roger Hill, and it shows that classic mothership, like a mother spaceship appearance of a supercell storm when it's on its own. So supercells, as we've been saying, supercells have a distinct appearance on Doppler radar, which often features a so-called hook echo on the lower left portion of the storm. The hook echo appendage extends southwest from the thunderstorm's main core, where large hail and heavy rain are typically located. When tornadoes are spawned by supercells, they are near the hook echo on the radar, so down the bottom portion of the storm, or the southwest corner, down here, and that's often the last part of the storm to come through. So the National Severe Storms Laboratory says fewer than 20% of all supercell thunderstorms produce tornadoes. However, supercells are responsible for spawning the vast majority of all tornadoes, violent ones in particular, and they also say that more research is underway to discover why some of these rotating thunderstorms are accompanied by tornadoes while others are not. Supercell thunderstorms are sometimes referred to as low precipitation or high precipitation, LP or HP. As the name implies, a LP or low precipitation supercell is accompanied by lighter amounts of precipitation, that is rain or hail. The type of supercell, or this type of supercell, is easy to spot in the plains because there is a clear view of the storm and the structure. HP or high precipitation supercells contain heavier concentration of rain and hail. The precipitation, or the rain and hail, can sometimes obscure the storm's structure, including wall clouds and tornadoes. Tornadoes that are obscured by heavy precipitation or rain are typically known as rain-wrapped, and they can be particularly dangerous because you may not know they're coming. And the other one that they talk about is tornadoes that happen at night time are also particularly dangerous for the same reason. So, when supercells develop in a volatile atmospheric environment, they can survive for dozens or even hundreds of miles over multiple hours. The best organized supercells may spawn multiple tornadoes, some of which can stay on the ground for a lengthy period of time. And this image here shows you a supercell storm from birth to death, and this was a long-lived one. Radar snapshots every 30 minutes. So it gives you an idea how long this storm lasted. Every 30 minutes of a classic long-lived supercell from central Alabama to North Georgia during the April 27, 2011 super outbreak. And it's just credit for the image there. So yeah, starting there, it's half hour, 1 hour, 1.5 hours. Actually, more than that. These are snapshots every half hour. So this is a very long-lived storm, and this was one of many supercells that day, and one of many that produced EF4 and EF5 tornadoes, some of which hit major urban centers on that day. It went down in history as one of America's worst super tornado outbreaks. And a more recent example from this year is a supercell in southwest Georgia on 22nd of January, which spawned a tornado in progress for 72 minutes along a 70-mile long path. So you've got low pressure systems in various regions of the world can spawn supercell thunderstorms when the atmospheric conditions are ripe. They can also occur in landfalling tropical storms and hurricanes, and this is usually in the outer bands. Now, the science behind how supercells form is pretty interesting. A supercell thunderstorm is characterized by a sustained and powerful rotating updraft of rising air. These storms originate in unstable air, accompanied by a particular type of changing wind direction at various altitudes in the atmosphere, known as wind shear. A common combination supportive of supercells is often found in the plain states in a southerly or southeasterly wind near ground level, and a southwesterly or westerly wind higher in the atmosphere. This combination of changing wind directions and speeds creates a horizontal rolling motion in the lower atmosphere, so parallel with the ground. The same rapidly rising air motions that form the thunderstorm turn this horizontal rotation into a vertical rotation, which can then be seen or spectacularly evident in the circular striations or layers visible in the cloud structure of the supercell. So yeah, there you can see certainly a vertical rotating storm, which is basically the horizontal rotation turned on its side. And that's the end of the article. So I've already gone through the different months of the year and how many tornadoes occur in each month. Where tornadoes are around the world, well, Italy actually gets a lot of tornadoes, which was surprising for me when I heard that. Yes, there are different types of tornadoes. I might just have a little look at that. Oh, we won't be looking at that. But yeah, that's probably enough anyway. Maybe we'll look at what's happening in Australia. As you can see, there's a bit of wet weather around where I live at the moment. I'm here near the ACT. See this cloud band that's streaming down today. It's Anzac Day, so it's the time of year where it typically turns cold. Anzac Day is considered as being the day where Canberra and the ACT can expect the weather to turn cold. And this year it's certainly not disappointing. Today is not too bad. It's 16 degrees and rain. But if I just look at the forecast, it's not saying how much rain to expect there, which is annoying. They don't show it for the day, the current day, but it's, I think, something like up to 20 mils or something for Canberra. If we just look down, see it's a cold front coming through today, and tomorrow it's going to be quite cold, 7 to 12. And then my birthday, the first sub-zero morning of the year. -1 to 14 on my birthday. Gotta look forward to that one. Be a nice big frost and a freezing cold southerly howling wind, and then warming up again a bit. Not too bad towards the end of the week. Of course, it's the dates that Jacob Wertling, who is from Minnesota in America, and Nathan Breeze, who is from Victoria in Australia, and neither of them are here on Earth anymore. They've moved on somewhere, if you believe in afterlife and that sort of stuff. Yeah, they've directed my attention to my birthday, Thursday, 27th of April, which is the anniversary of the 2011 super tornado outbreak in America. The number 69's come up a lot for me lately, and that is actually the number of days between Jake's birthday on the 17th of February and my birthday. So I'm pretty sure something might be going to happen on the 27th of April. Not in Australia, I can't see much happening in Australia, except for maybe a cyclone up off Darwin. There's a possibility of that, which would be unusual for April. That's getting really late. So yeah, there is that. But I'm thinking more of America, because they are forecasting thunderstorms, some severe thunderstorms on the Wednesday in America. And of course, when it's my birthday in Australia, it's still Wednesday in the United States, because it's a 15-hour time difference, at least between New South Wales and Texas, say. It's exactly 15 hours. And, you know, the tornado risk is there for Wednesday, or the severe thunderstorm risk, and the slight tornado risk for Wednesday. And then moving ahead, the severe thunderstorm risk returns on Friday, which is, what, the 28th? I've been talking about the 28 a bit too, 28 days later. Some stuff to do with that number, 28. So the severe thunderstorm risk returns Friday and continues into the weekend. And the other date that Jake and Nathan seem to have flagged, or helped me to flag, is Sunday 30th of April in America, which of course will be Monday 1st of May in Australia. And it's 16 days before. Interesting there, a little reflection in the forecast temperatures actually, because Monday the 1st of May is the 18th day after Good Friday. You know how they say Sunday, Easter Sunday, you know, Jesus rose again on the third day. Well, the 18th day would be Monday 1st of May, which is actually 17 days after Good Friday. And Sunday 30th of April is in the United States is actually 16 days after Good Friday, which is why I flagged that date to begin with, because I just have a feeling Jesus was aged much younger than is commonly believed. I think he was around 16, 17 or 18, somewhere around there. So that's sort of the tail end of this next severe weather outbreak in the United States. And Australia could have a active cyclone up north, very late for a cyclone. And you can see that reflected if I just look at you can see the cloud formation up there across northern Australia. That is going to give rise potentially to a tropical cyclone, certainly to a tropical low over the coming days. And just looking at the rainfall forecast, I mean, today there's a lot of rain associated with that cloud mass up there. Darwin's up here. We've got a lot of rain happening up there now. We've got rain down in our part of the world today too, with a strong cold front coming through. And if I just click forward to Wednesday, we've still got some rain in this part of the world, but it's mostly just going to be wet, cold and windy, or more cold and windy than wet. You can really see the rainfall ramping up here up north. And if I move ahead another day to Thursday, which is my birthday, you can really see that intensification happening just there. And that is indicative of a tropical low that could be verging on a tropical cyclone. No cyclone actually forecast just yet, but there is talk of a possibility. And again, you've got that really intense purple there, which is indicative of a strong tropical low, potentially a cyclone. So very late in the year to be seeing that. And the current rain radar, just click on Canberra. Yeah, we're going to have a wet day today for sure. A lot of rain moving in now from the west. This big cold front that's coming. And it's almost arrived at our place now. It's going to be raining heavy here in a few minutes. And probably for most of today. And they smack bang on Anzac Day 2017. And it remains to be seen if we're going to see any, what would you say, coincidental, synchronistic, magical reflections in the weather to do with how old Josh was when he died. Crazy idea, but who knows? I think my ideas on who Jesus was, and I call him Josh because I don't like a lot of the stuff that a lot of Christians do. I don't like the traditional image of Jesus. It means nothing to me. And I notice a lot of Christians are climate change deniers, which I just find bizarre. The way they've politicized that issue. That's a conservative thing. It's not all Christians. The Pope, for example, came out and said, you know, climate change is a big deal and we need to do something. Need to take it seriously. At least admit that it's a problem. And I guess my problem with a lot of Christians is they just deny things. They just say, not happening, don't know. And they do that with same-sex attraction, which I've talked a lot about in my previous videos. You still have Christians that say, oh, it's not natural, it's not normal, and blah, blah, blah. And it's a mental illness, whatever. A lot of rubbish. So, we'll wait and see if there's a reflection in the weather. You know, I'm totally into science as well. Just because I'm into possibilities that go beyond science doesn't mean that I don't accept and appreciate science. I most certainly do. So, till next time.